This presentation is part of the TI-Nfocus AP Calculus video series. In this video, I'll discuss some technology solutions and problem extensions for the 2018 AP Calculus exam free response question AB4 BC4. My name is Steve Kokoska. I'm a professor at Bloomsburg University in Pennsylvania, and I'm a former AP Calculus chief reader. Here's an outline of the information presented in this video. I'll start by reviewing the free response question, and then the scoring guidelines used at the AP Calculus reading. And I'll focus on the solutions presented in these guidelines, not how the points were awarded. Now, even though this question was not calculator active, I'll show you how to use technology to explore and solve parts of this question, where appropriate. And because the free response questions are usually very comprehensive, I'll suggest some extensions, additional AP Calculus type questions associated with the information given in the problem. And some of these questions may be calculator active. This problem involves the height of a tree and a table of values. The height is given by a twice differentiable function h, and selected values of h of t are given in the table. In Part A, we need to use the data in the table to estimate h prime of 6, and we need to interpret the meaning of h prime of 6 using correct units. In Part B, we need to explain why there must be at least one time t for t in the interval 2 to 10, such that h prime of t is equal to 2. In Part C, we need to use a trapezoidal sum to estimate the average height of the tree over the interval 2 to 10. And in Part D, a new function capital G is introduced, which models the height of the tree as a function of its diameter. The diameter of the tree is increasing at a rate of 0.03 meters per year when the tree is 50 meters tall. And we need to use this model to determine the change in height of the tree with respect to time when the tree is 50 meters tall. Part A was worth 2 points. 1 point for finding the best estimate of h prime of 6, and 1 point for interpretation using the correct units. Part B was also worth 2 points. 1 point for writing an appropriate quotient that results in a secant line slope of 2, and 1 point for demonstrating the conclusion is true using the mean value theorem. Part C was worth 2 points. 1 point for writing a correct trapezoidal sum using the values in the table, and 1 point for finding an approximation to the average height of the tree over the interval 2 to 10. Part D was worth 3 points. 2 points for finding the derivative of g with respect to t, and 1 point for the final answer, the rate of change of the height of the tree with respect to time when the tree is 50 meters tall. Note that there's a maximum of 1 out of 3 points in this part if the student does not use the chain rule. Even though this question was not calculator active, I'm going to show some ways to explore and confirm the solutions where appropriate. Now, that said, I don't think we need technology in Parts A or B. In Part A, the student simply needs to find the appropriate quotient that leads to the best approximation for h prime of 6. And in this problem, that means h of 7 minus h of 5 divided by 7 minus 5. In the interpretation, the student must include the word rate, the units meters per year, and indicate that h prime of 6 refers to a specific instant in time, not an interval. In Part B, the student needs to use the table of values, search a little, use trial and error, to find an interval such that the difference quotient produces a secant line of slope 2. Using the interval 3 to 5, we have h of 5 minus h of 3 divided by 5 minus 3 is equal to 2. Now, to justify the conclusion using the mean value theorem, we need to make sure that the assumptions are true. Since we're given that h is differentiable, we know that h is also continuous. And therefore, by the mean value theorem, there must exist a value of c in the interval 3 to 5, so that h prime of c is equal to 2. Here's a problem extension to this free response question. In part A, explain why there must be at least one time t for t between 2 and 10, so that h prime of t is equal to 1.9. And in part B, use the mean value theorem twice and the intermediate value theorem once to explain why there must be at least one time t for t between 2 and 10, so that h prime of t is equal to 2. I think part A is good practice for this type of a problem. We need to use the table of values again, search some more, use trial and error, and again find an interval such that the difference quotient produces a secant line of slope 1.9. And using the interval 2 to 7 works, that is, the difference quotient is 1.9. Now, since we're given that h is differentiable, we know that h is also continuous, and therefore by the mean value theorem, there's a value of c between 2 and 7, such that h prime of c is equal to 1.9. To solve part C, we need to first find a trapezoidal sum using the subintervals as indicated by the table of values. And then, to find an approximation to the average height of the tree over the interval 2 to 10, we need to multiply this trapezoidal sum by 1 divided by 10 minus 2, or 1/8. Here's a technology solution to part C using the TI-Nspire. In a lists and spreadsheet page, I created a column for the values of t and a column for the corresponding values of h of t, and I called this variable h. So this is simply a vertical copy of the table given in this free response question. And because this is a CAS calculator, notice that I entered 3/2 rather than 1.5, just so that I could find an exact symbolic answer if possible. On a calculator page, I wrote an expression for a trapezoidal sum using the variables defined on the lists and spreadsheet page. The area of each trapezoid is the sum of the bases divided by 2 times the height. Then I multiplied this trapezoid sum by 1/8. Here's the symbolic answer, and here's the numerical value for this approximation to the average height of the tree. Here's a problem extension. First, sketch a graph to illustrate the trapezoidal sum found in the free response question part C. In part B, use a left Riemann sum with the 4 subintervals indicated by the data in the table to approximate the integral from 2 to 10 of h of t dt. And in part C, use a right Riemann sum. And in part D, use the left and the right Riemann sums to find the trapezoidal sum. And finally, in part E, if we assume that the height of the tree is increasing, determine whether the left and then the right Riemann sum is an overestimate or an underestimate. And don't forget to explain your reasoning. I'm going to solve parts B, C, and D, especially because many students tried to solve this free response question using this approach. And I'll leave parts A and E to you. Here's the left Riemann sum using 4 subintervals as indicated by the table of values. Here's the right Riemann sum, and the trapezoidal sum is the arithmetic mean of the left and the right Riemann sums. Here are some technology solutions. Using the same lists and spreadsheet page with the values of t and h, here's the left Riemann sum, here's the right Riemann sum, And here's the trapezoidal sum. To solve part D of this free response question, we first need to determine the diameter of the tree when the height is 50. So we set capital G of x equal to 50 and solve for x. Then take the derivative of g with respect to t, interpreting x as a function of t. So we need to use the quotient rule and the chain rule. Finally, we evaluate the derivative dg dt at x equal 1. The rate of change of the height of the tree with respect to time when the tree is 50 meters tall is 3/4 meters per year. Here's a quick technology solution to this problem. First, I defined the function g, and then I defined another function as the derivative of g with respect to x. And next, I simply evaluated the derivative of g with respect to x at x equal 1 and multiplied by the rate of change of the diameter when the height is 50 meters. Here's one more problem extension associated with this free response question. Suppose this time that the rate of growth of the tree is modeled by a function small h on the interval 2 to 15. Selected values of h are given in the table. And suppose we know that the height of the tree at time t equal 2 is 1.5 meters. Use a left Riemann sum with 5 subintervals as indicated in the table to estimate the total amount the tree grows over the interval 2 to 15. Then use this answer to find an estimate of the height of the tree after 15 years. And finally, suppose the rate of growth of the tree can be modeled by a function g. Use this function to estimate the height of the tree after 15 years. I hope this video gives you some good ideas for additional practice AP Calculus exam type questions, and of how to use technology to solve some of the parts of this problem, and to explore, confirm, and visualize results. And just a reminder, there are lots of valuable resources on the TI website. Material is there involving technology and calculus, classroom activities, and there are lots of calculator tips and tricks for test success.